May 8th, 2025. White smoke curls above the Sistine Chapel at the Vatican. Habemus Papam. We have a Pope, as Cardinal Robert Prevost steps onto the balcony as Pope Leo XIV, chosen by 133 cardinals in one of the most secretive elections on earth. Here is what baffles outsiders. With over 100 voters and a 2/3 supermajority requirement, you might expect round after round of deadlock. Yet, Leo XIV needed just 4 ballots to be elected Pope. Pope Francis, just 5. These numbers tell a story, and today we'll show you how that story emerges straight out of a scribbled equation. In a modern conclave, the electorate is limited to cardinals under the age of 80. This time, that meant exactly 133 voters. They convene in the Sistine Chapel and may cast up to 4 secret ballots per day, 2 in the morning and 2 in the afternoon, until a clear consensus emerges. To elect a pope, any candidate must secure a strict 2/3 supermajority, which translates to 89 votes out of the 133. After each ballot, the paper slips are burnt with chemicals that tint the smoke. Black if no one reaches the threshold, and white the instant a new pontiff is chosen. Today, we'll build a simple back-of-the-envelope math model that explains why papal elections on average finish in about 5 ballots. Alright, ballot number 1 is in. History shows we usually start with a handful of serious papabile and a flock of long shot names. Let's split the pie. The top 3 contenders together own X number of votes. I'll put a subscript 1 to denote it's at the end of the first ballot. The bottom block, everybody else owns the rest, so B1 is N minus X1. For a typical modern conclave, archives suggest the frontrunners start with about 70% of the votes. So today, let's set X1 to be 0.7 N, which makes the bottom block B1 to be about 0.3 N, where N is 133, our total electorate for the 2025 conclave. At every new ballot, a slice of the vote share in the bottom block B peels away and rallies to the leading candidates in the top block X. We'll call that fraction F. Empirically, F is on the larger side, around 0.6 to 0.8, because once a name looks non-viable or strong alliances are made, the pressure to switch is immense. So after the second ballot, B2 is 1 minus F times the original B1. After 3 ballots, B3 is 1 minus F squared of B1, and so on and so forth. In general, at the nth ballot, Bn is 1 minus F to the n minus 1 of the original population in the bottom block B. That is just a geometric sequence. A fraction 1 minus F gets left behind every time in the bottom block B. And yes, if one frontrunner stumbles, the rallying votes simply lift a new name into the top trio. The equation shrinks whoever is outside the top 3, not necessarily the same cardinals. So how many rounds until only 3 names matter? As the fraction of votes in the bottom set B dwindles away, let's say once Bn reaches below a certain threshold epsilon, only then the top 3 names remain in the race. We can set this Bn to be less than epsilon and then solve for n, the number of ballots required, and it comes out to be logarithmic in the ratio of the threshold to the initial number of votes in B. Plug in our conservative estimates from modern conclaves, with B1 about 30% of the total, a threshold epsilon of about 5% of the total votes, and a mid-range estimate for F about 0.6 gives us N to be about 2.95. So a total of 3 ballots are required to thin down with the top 3. Push F to 0.7, a stronger rallying, and you're down to N about 2.4. Still, 3 ballots needed in practice. Crank F to 0.8, and the math gives N to be about 2.1. 2 ballots plus some change. In other words, no realistic rally rate stretches the winnowing past the 3rd round. That lines up perfectly with the diaries. In 2013, after ballot number 2, only Bergoglio, Scola, and Ouellette had meaningful totals. In 2005, after the 3rd round, the votes were already coalesced around Ratzinger and Bergoglio, with just crumbs elsewhere. 1978, John Paul I's conclave shed its fringe by the 3rd count, despite starting out with a dozen names. Our fraction F lumps all conclave dynamics, quiet corridor whispers, national or theological blocks, long-standing friendships, and everything else, all into one convenient number. It's a simplification, yes, but it's fine for a simple first-order model. With the field now trimmed to 3 serious papabile, phase 2 begins. Call the 3 leading cardinals A, B, and C, holding VA, VB, and VC votes respectively, numbers that always add up to the total number of votes N. In the next ballot, we model the N cardinals to vote independently, with their choices depending only on their vote from the previous round. This is what is called a Markov process. Voting is memoryless, but only depends on the last vote cast. Again, it's a simplification, yes, yet it's rich enough to capture the essential jockeying we see in a real conclave. To do this, I am going to define a 3x3 Markov transition matrix, which captures the probabilities of voting for either of the 3 contenders based on your last vote. If you voted for frontrunner A, you are comfortable sticking with it and voting for them again. In matrix speak, that row is just 1, 0, 0. You stay put, period. If you voted for Cardinal B, you may have a non-zero inkling, P0, to switch, even if B has almost the same number of votes as A. But this probability to switch to A grows if there's a wider margin delta AB. What's left, 1 minus this, is the probability you stick with B. Now, for the 3rd place exodus. If you voted for C, there is a higher chance you would want to switch to either A or B. Let's call this chance alpha. It's typically about 50% or so, I would say. You want to stay with C with the probability of 1 minus alpha, else you split your chances to switch over to A or B proportionate to the vote gap they have from C. Now comes the fun part. Closed form algebra would have to chase thousands of ever-shifting ballot configurations. But instead, we can run a Monte Carlo simulation that sidesteps that maze. We simply let the computer play the conclave. Draw 133 random votes according to our Markov rules, update the votes till one cardinal gets 2/3 of the vote and gets elected Pope. And then rerun this experiment 50,000 times. By averaging these digital reruns, we see the typical and extreme ballot counts. Randomness generates the stats for us instead of forcing us to untangle the entire probability tree by hand. To do this, I will choose what I think are reasonable approximations for P0 and alpha. The baseline inkling to switch from the runner-up on each ballot is, say, about 10%. For alpha, I will choose a conservative estimate of about 0.5, where cardinals might be somewhat dug into ideological trenches and not very willing to switch. As a representative starting snapshot, I will take the case where the front runner has a moderate lead. Think 55, 45, 33. Now, 50,000 digital conclaves later, the histogram lines up like this. It takes about 2.4 ballots on average in phase 2 to get to a 2/3 supermajority. So that's between 2 and 3 ballots, though sometimes it can even go up to 5 ballots. Add this mean to the 3 ballots from the winnowing of phase 1 and we get the average of a total of about 5 to 6 ballots required to go from over 100 possibilities to habemus papam. In cases where the conclave starts phase 2 with a clear majority for the frontrunner, someone who is already close to the 2/3 vote, our Monte Carlo runs show it will take just 1 ballot in this phase to go over the finish line. That aligns almost perfectly with the modern record. Pope Paul VI in 1963 closed in 6 ballots. Benedict XVI in 2005 and Francis in 2013 needed 4 and 5 ballots respectively. And the brand new conclave of Leo XIV wrapped up in just 4 ballots. Faster sprints, such as Pius XII's 3-ballot election in 1939, simply correspond to a clear majority start plus 1 brisk rally step in our model. While slower marathons, like John XXIII's 11 ballots in 1958, reflect a much smaller defection parameter, a conclave where blocks were dug in, and alpha might have been closer to about 0.2. In other words, by tuning just 2 probabilities, our scribbled equations trace the entire historic spread, pinning the average exactly where the white smoke most often rises, around the 5th ballot. And so, we close our discussion with an unexpected harmony, a sacred rite shaped by prayer and discernment, yet unfolding in rhythms that a few scribbled equations can trace. So the next time you see that white plume curl over the Vatican skyline, pause for both halves of the marvel, the spiritual weight of 2,000 years and the elegant, almost inevitable arithmetic carrying it towards its moment of revelation. Thanks for watching, and I'll see you next time.